A very good day to our model lecturer and everyone who will be watching this presentation. This is Group 10 presentation for Data Mining Module. Our group consists of 3 members, Park Ji-soo, Lee Jae-hyuk, and Wei Chen-si. This is the outlines of our whole presentation. We have Introduction Literature Review, which is the taxonomy mapping, problem statement, materials and methods used, limitation and future work, followed by conclusion. I'll now go on with the introduction. So basically our topic is to study the sinking of Titanic. We are taking the data source from different places and get them analyzed to find who had the higher rate of survival and what are the factors affecting the survival from Titanic. Various types of machine learning methods were utilized for data analysis. Our objective is to get prepared for future from these results of data analysis to find out which factor had the greatest influence on the survival rate and check to see if a specific person can survive from Titanic. This is our taxonomy mapping, which is part of the literature review. As you can see here, these are the key elements that summarize our whole literature review. We came up with this taxonomy mapping after analyzing 15 related papers on survival from Titanic. These elements would be data source, attribute, data pre-processing, statistical model, data exploration, model development, model evaluation, visualization, and lastly, limitation. Next part is on the problem statement. Each of us have our own special characteristic. In Titanic era, people even had different classes. Only after tragic sinking of Titanic, which took away thousands of lives, people started to take an interest to find out what is the factor that increased the survival rate from Titanic. It is quite possible that knowing these results can help people to gain knowledge about who should be prioritized to be rescued first in case of any shipwrecks. Staffs from marine police might be affected as well because they will be the one on the very first line to rescue people in any incidents on oceans. This problem can be of its interest because we never want these tragic incidents to be repeated in the future. Next is on the research questions, and these will outline what we want to find out from this project. We have 3 questions. The first one, are we able to predict if a specific person can survive from Titanic? Next, who were prioritized to be saved from Titanic? And followed by which machine learning models works the best for predicting survival rates? For research objectives, evaluation should be done on data to conclude if a specific person can survive or not. Then, we gotta find out which factor had the greatest impact on the survival rate. After that, we will be evaluating the accuracy of the models. So this table shows the summary with its outcomes. For question 1, necessary machine learning models will be built to make precision. Question 2, we would be able to identify the factors that had the greatest impact on the survival rate. Last question, we must identify which machine learning model provides the highest accuracy. Now I'll pass on the mic to Chen-si to continue with materials and methods.
Thank you, Ji-soo. I will continue with the research objectives. As you can see here, there's a flowchart of process. First, we'll start with data acquisition to obtain data. Second, data preparation is to clean and transform data for analysis. Third, EDA, which is finding patterns and analyzing them. Fourth, model development, which is developing machine learning models and evaluating them. Fifth, visualization and communication to represent the results. And lastly, deploy and maintain to test a model and improve on it. Next. Now I would like to talk about the data acquisition. The data set we used is mainly collected from Encyclopedia Titanica, which was uploaded on the Kaggle website. Our training set consists of 712 observations and 12 features. The 12 features include 8 quantitative features and 4 quantitative features. For the data description, you can see that the description of each feature and some keys are included in this table. For example, survived represents the results of passenger's survival. So 0 means that the passenger didn't survive, and 1 means that the passenger survived. Next. So let me move to the data processing. First, we need to deal with missing values and aligns. the missing values are handled differently according to different situations. For outlines, we found outlines in some columns, but those outlines were due to characteristics of the feature itself, not error. So to avoid the overfitting, we don't deal with these outlines. Second, we combine some highly correlated columns like fire and P clause. Then, for the convenience of model training, we divided each into different groups and divided the categorical features into numerical features. Finally, in order to improve the model accuracy, feature selection and feature extraction were applied. Next, from this table, you can see that there are missing values for three features in Titanic dataset. The missing value of age will be filled with mean. Cabin's missing value were very high, according for 77 of the data. So we removed this column. Finally, Embarked only have two missing values, so we dropped the rows that have the missing value. Next, I would like to talk about the data transformation. There we found that the second position of the passenger's name is the passenger's title. So we extracted the title and grouped it. Then the title is converted from a categorical feature to numerical feature. For sex and embarked, the categorical features are also converted to numerical features for convenience of model training. Next, in order for our model to work properly and better, adhere with standardize the column file. As you can see, the file to be scaled in a specific range. It will help us improve the accuracy of the model. Next, here in order to reduce the highly calculation input variables, we first parallelized the correlation between features and survival using the heat map. After feature extraction through PCA, we found that the features of PCOS and the fire were very similar. So we reduced the two clones to a single clone. After dimension reduction by OLS, we found that the purge wasn't very important for survival, so we deleted the purge clone. Now I would like to pass it to Jay for the next part.
Okay, thank you, Chelsea. Now I'll continue with methods of analysis, which is done after pre-processing. To analyze data, we have explored dataset through four main methods. First, analyzing the column to identify and remove meaningless or unique data. Second, graph to visualize relationship between dependent variables and independent variables. Third, heat map to identify correlationship between independent variables. And lastly, OLS regression to evaluate if selected variables have good relationship with dependent variable. Now we'll look at some graphs which has clear relationship between variables and survivability. In terms of age group 0, which has ages from 0 to 9, have higher survivability for all age groups, and survivability decrease as age group increases. When including genders to this age group, all males have less than 20% survivability in all age except of age group 0. Whereas for females, they have more than 60% survivability in all age. This clearly shows females have higher survivability than males. Looking at other graphs with different features, we can see that upper class and higher fare increases survivability. Having more siblings or spouses decrease survivability, or even placement of embark affects the survivability of passengers. Another method we have taught was heat map. As you can see from here, there are 3 pairs of variables which has high correlation above 0.4. These independent variables are handled accordingly in the feature selection and extraction stage. Now moving on to model development, we have first extracted 20% of data as final test data to last validate our developed model. This data does not involve in EDA, thus is completely unrelated to model development. With remaining 80% of data, we have pre-processed and performed EDA. Then from processed dataset, another 80% of data was splitted and used to train machine learning models with different classification algorithms like SVM or decision tree. The remaining data was used to evaluate the developed models. The table here shows evaluation metrics of different machine learning models developed among 6 algorithms, which is random forest. It had the highest accuracy of 77.5%, as well as highest of recall and F1 scores. Since F1 is combination of these 3 other scores, the random forest classifier, which has the highest F1 score, is decided as the best machine learning algorithm. As for the results in discussion, we have confusion metrics to show how random forest algorithm predicted our evaluated dataset. It shows correct death prediction of 79% accuracy and correct survival prediction with 75% accuracy. The ROC curve below visualizes the specificity and sensitivity in confusion metrics. This allows different algorithms to be directly in general or for different thresholds. The ROC and AUC score of our model was 0.78, indicating that the probability of accurate prediction was about 78%. The prediction result of our model is satisfying, yet not perfect. Additionally, here it shows a pie chart which shows which variables had greater feature importance when predicting the observability in random forest algorithm. Here, combined variables of fair and peak class show the highest importance of 44%, followed by gender of 32%. After machine learning model was developed, we had deployed it to the real-world program, starting with our final test data, which we have splitted before data cleaning. The data pre-processed as how machine learning model requires. The prediction model was successful with 80% accuracy, similar to our expected results. This proved our model was stable. Additional improvement could be attempted, and we have tried to normalize the whole dataset just before developing machine learning model. In our dataset, the accuracy of random forest on test and train set increased from 77.4 to 78.1%. Although this was a small improvement, it was a successful, and further improvements on our machine learning model could be made. That was all for my part, and now I'll pass it back to Jisoo for future works and conclusion.
Thank you, Jay. Next is on the limitation and the future work. Our first limitation was that some of the data in the key attributes were missing. This is very crucial as it will affect the overall performances of all our models that were developed. Data in the cabin attributes was not enough, and this made us difficult to find out the correlations between the cabin and the target variable, which is the survival. Next limitation was due to the size of the dataset. The data was too small, which caused the results of the trained data set and the test data set being differed dramatically. The accuracy could not be calculated from the validation data as there was no target variable. In the future, to solve this limitation, cross-validation methods will be used to deal with the little dataset. We will be continuing our work to resample the dataset to evaluate the machine learning models on a limited data sample. Few more classifiers can also be added, as well as artificial neural networks to minimize the conversion errors. Next is on the conclusion. Our final goal of this data analyzation in the end is to find out what are the factors that really had an impact on the survival rate from Titanic. With the respective steps being followed accordingly, we developed several models in the end to make a conclusion on the models with the higher precision. Only the groups with high correlations were taken for model development. We have utilized linear regression, naive Bayes, random forest, support vector machine, decision tree, and k-mean clustering for model development. It was concluded that the random forest algorithm produced the highest precision with the value of 0.774 and k-mean clustering with the lowest precision with the value of 0.07. We were able to conclude that the top most important factors that affected the survival rate were gender, age, followed by people's class. This sums up our presentation for our project. Thank you very much.